everyone, and welcome back to the chemistry box, your one-step chemistry guide. In the previous video, we started talking about the different types of structural isomerism, जिसमें हमने cover किया है the first three types, that is chain, position and functional. In this video, we are going to continue with the rest of the three types of structural isomerism. So let's dig into the video. So let's start about metamerism. Now, what is metamerism? Metamerism means the compounds that we are going to take here will be having the same molecular formula, but there will be different number of carbon atoms on both the side of the functional group, which means that both the compounds will be having the same functional group, only the number of carbon atoms across the functional group will be different. The example that I have taken over here is having the molecular formula C4H10O. This is an ether molecule. Now here we have two molecules, both of them are ethers. Only thing the difference we can see over here is, here we have two carbon atoms on this side of oxygen and two carbon atoms on that side of oxygen. And in the other molecule that we have over here, we have three carbon atoms on this side of oxygen and only one carbon atom on that side. Here we have a molecule ethoxyethane, which is a symmetrical ether. And here we have methoxypropane, which is an unsymmetrical ether, but both the compounds will be showing the same molecular formula, that is C4H10O. In such a case, where you have the same functional group, only the length of carbon atom chain will be different on both sides of the functional group. Such a phenomenon is called as metamerism, and these compounds are metamers of each other. Let's go on to the next one. We move on to the next part, that is tautomerism. Now, what is tautomerism? Well, tautomerism is having same molecular formula for two different structures, but these two structures are just interconvertible forms of each other. That means what we have here is they are two different interconvertible structures of each other. Now what happens here is I have two compounds over here. First one is propanone. I have an acetone molecule over here where you can see the functional group is ketone. Now if I write this molecule like this, what happens here is this oxygen will try to attract this hydrogen when this double bond or the pi bond shifts over to oxygen. This hydrogen will go to the oxygen, leaving this bond in between these two carbon atoms, and we get the other compound that we have here is propene 2-ol or 2-propanol. As you can see that in this compound you have two different functional groups, that is alkene and alcohol. In a way we can call it enol, where you have alkene and alcohol together. So this is a functional group which represents for this molecule, while for this molecule I can write it as keto form. Now as you can see how these two structures are just interconvertible for each other, and therefore they are always in a dynamic equilibrium. Now therefore tautomerism always exists between two different molecules which are continuously in a dynamic equilibrium. There are different names given for tautomerism as desmotropism, cryptomerism, allotropism and dynamic isomerism. So just for understanding, we need to keep in mind that in tautomerism, the structures which are isomers or tautomers of each other, they will be existing in a dynamic equilibrium. These two structures are interconvertible forms of each other. Also, as we can understand that we have two different functional groups and still with the same molecular formula, always you should remember that tautomers are functional isomers of each other, since we have two different functional groups over here. So, I hope tautomerism is clear to you. Let's move on to the last one. We now head on to the last part of structural isomerism, that is ring chain isomerism. Now, what is ring chain isomerism is completely clear by its name itself. Now, here we have the same molecular formula, but one of the isomer will be having a ring structure like this, while the other isomer will be an open chain structure. I have taken the simplest example that we can take, that is propene, and here I have cyclopropane. The molecular formula for both of them is C3H6. Now as you can see, both the molecules have the same molecular formula, but one of them is open chain structure while the other one is a closed ring chain structure. We can also have different other examples in this regard. I hope so far we have got all our doubts clear with the types of structural isomerism. But still, if you have any more doubts, remember to put them in the comments below. So with this, we complete the different types of structural isomerism. If you like this video, do not forget to press the like button. Also subscribe to the channel so that you don't miss any of the further videos. Share this video with your friends. Till then, I see you in the next video. Bye bye.